This is the 2015 higher level question B2 on axonometric. There is a bit of a mix of axonometric and of intersecting solids on this question, so it's an interesting question. No curves or anything, no cylinders, no cones, nothing like that included here, so the axonometric part is actually not too bad. What they have added in then, just to make it a bit more challenging, is intersecting solids dropped in there as well. So, as I said, interesting question here. Nice one to draw, not too difficult. Quite a large question, so if you're doing this at home, if you have A2 paper, work on A2. I'm pretty sure I can get the whole thing to fit here on an A3 page, so what I'll do is I'll give you the starting point and the few main dimensions, so that we can try and ensure that it fits. It's the height that we catch here. If you're doing it at home, maybe, and if you only have A3, turn the page portrait. So to get started, let's have a quick read through the question. We'll highlight the key words and key points that we're being asked to work with, and the key detail, and we'll get started then. First off, the 3D graphic below shows an exterior light. In the cap of the light, a regular hexagonal prism that's going to be used for the hexagonal prism penetrates a square based pyramid. So the prism penetrates the pyramid. Figure B2 below shows the incomplete isometric. So it's not trimetric, it's not dimetric, it's isometric projection. All three angles equal, using the axonometric axis method of the two solids which penetrate each other to plan an incomplete elevation. So obviously there's something missing there. Incomplete elevation are shown in their required positions. A pictorial view of the intersecting solids is also shown. Draw the axonometric axes X, Y and Z and the equilateral. They're giving us a lot of hints here. It's good now. Equilateral triangle A, B and C, because they didn't really need to tell us that. They told us it's isometric projection, so we should know that it's an equilateral triangle. But anyway, the hint is there. Why not? We're going to use it. Which has a side of 110, and again, that didn't necessarily need to be mentioned in the question because it's shown down here as 110, and that dimension lines up with the edge, the green edge AB. Draw the plan, an incomplete elevation, orientated as shown. That's fine. Complete the drawing showing all lines of interpenetration in the axonometric projection and in the elevations. So there's going to be a little bit of difficulty in there, of course, for that one. I'm not going to get into that yet. I'm not going to talk about this, about the interpenetration and finishing this view or finishing this view. Basically, we're going to get started. We're going to set up the three axes, and you know, we read the question and highlighted the key points, and we have our little bit of information. The key information is it's a regular hexagon and it's a square based pyramid, it's isometric, it's equilateral, and it's 110. That's our key information. And if we look at part A, they're giving us the exact structure of how we draw this. Draw the axonometric axis X, Y and Z first, then draw the equilateral triangle A, B and C, which is 110 mil. So that's exactly what we're going to do. Once we have that done, we're going to go about developing the planes and showing the true shape of what lies inside each trace. To put this aside, so I can get started. I've taken a look at this before the video, and I've just picked out the key terms here that will be coming across throughout the video. So if anyone wants to kind of zoom in on that and see the key terms, you'll also see that, like most questions, you know, there's no such thing as topic only questions anymore. There's a mixing of various principles from different areas, which is the way the DCG should be. To get started in this one, we're going to come from the bottom of the page. I'm going to measure up 176. And from the left hand side then, I'm going to measure in 100. Now that's the center of my three axes. It is isometric projection, so I can draw the three axes in as vertical at 30 degrees and at 30 degrees the opposite way. They've given a measurement for the base of the triangle of the axonometric equilateral triangle of 110. So on my construction line I use just to find that point, I'm going to measure out 55 mil. And I might just drop that down. That's all light because that's only construction work. But from there, if that's 55 mil to the left, and this is isometric projection, well, that's going to be my 110 total length. That means I can also draw in the right side trace and the left side trace. So there's my 3 axes and my 3 traces of the axonometric plane dropped in right there. I'm going to label my axes now. So, excuse me, in this case here, the elevation is seen on this right hand side, so that has to be the XY plane. And then the remaining one for the floor here, of course, is the Z axis. I'm going to move down to plan first. I think it's the easiest one to work with. I'll do the usual. I'll just take the trace that lies on the horizontal plane and I'll project down the right side of it. I'll project down the left side of it. And if you're on A2 paper or if you are on a portrait sheet, you'll have no problem fitting this. I'm pretty sure what I need to do is go down 88 millimeters or so from the original trace to the new position of the trace down here. Down 88 mil will give me my starting point right there. This is just out of complete habit and just to try and set up good practice really. I'm going to bisect the line to find the center, even though I know for a fact I don't need to. I'm going to do it out of, it really is kind of out of habit, because for all of these drawings I would teach our students to bisect the line, make sure they get in the habit, but what you'll find is it lines up perfectly with that y-axis anyway. Drop in your semicircle there. So from that bisect point, just check now, is it all accurate? It is. From that bisect point there we get our semicircle, and then we can bring down the y-axis and make sure you project it down. You know, show your projections. Don't want anyone to think that you're guessing anything. Show your projection, and once you've that done, you get one vertical plane and another vertical plane. Now the good thing about this is the 110 mil size they gave us is so big that we should be very, very accurate. I think, you know, there shouldn't be an issue with accuracy there, with this guy being the perfect 90 degrees. To work with the object itself, all they have given us this time is they've just given us the diagonal only, so we know that that is the diagonal of the object right there. What I'm going to do is I'm just going to mirror this point to the center and down. You could go about this in any way really. You could, this is going to be 45 and 45. I could come back out at 45 degrees. And you know what, that's just as handy. I might just do that instead. What I was thinking of doing there was taking that distance of the pyramid through the center point and just mirroring it down. There is no need. We'll just remove that one step because it's going to end up being 45 degrees. Now I am exactly on the edge of the page here, so it is a very, very tight drawing for an A3 page, but anyway, it's fitting. That whole outer edge is solid. That's completely unobstructed, nothing cuts down to the ground, so that full outer edge there can be seen. There. My two sets of edges up to the top of the pyramid are in there, but I don't know yet how much of them can be seen and cannot be seen. I'll just have to look back to my drawing now. At this stage, back to the exam paper here, I have just basically set up my X, Y and Z axes my green, the traces of the axonometric plane, and down in plan I have developed the portion of the axonometric. I've developed a portion of the horizontal plane, that lies inside the axonometric, and there we have our 90-degree corner between the two walls. I'm going to be adding a lot of notes and colour and all onto this later on there to help with the understanding of this topic. Even for now, I'd like to add one or two little bits maybe onto the papers here. If you have the question with you, add this on. There's the X, Y and Z axis, which give us in vertical, vertical and horizontal. There's the HP, there's the VP, and there's the EVP right there. Structured, all structured around your X-axis, your Z-axis, and then the Y-axis standing up. So basically we have looked down on top of the object and we have seen what we can view in plan. I'm going to finish off this plan right now, and there's just again a good bit of information given, which is great. They didn't really need to give us the fact that the circle here is 15 out and 15 out, because if a hexagon fits in a circle, the side length of the hexagon is equal to the radius of the circle. So if that's a side length of 30, then the radius of the circle is 30 as well, which means the total width would be 60. So I'm going to just start off there by drawing the circle in from the center point, radius 30. I'm going to use my compass then to plot out all the points on the hexagon. So radius 30, so along any line at all, measure your 30 mil. I do know that I need this 45-degree line here in a while, so I'll just drop it in there nice and light, keep it there for me. So I have my 30 mil marked out along here, and again that could have been marked anywhere at all. There's my 30, and keep that light. There's no purpose to that except to give us some points. That is a point on the hexagon, and so is that, and I can just find the rest by doing that and that, because the relationship between the radius of the circle and the inscribed hexagon is that the radius equals the side length of the hexagon. If I'm accurate here, I should be parallel on the hexagon, and I am. And then join them up. What I might then add in is just finish off the square base pyramid and add in the lines until they touch that hexagonal based prism. So there's my two objects. That is the plan completely finished. Nothing else to add in there except some notes and some colour. So I'm going to just pause the video. I'm going to add in some colour onto the object there. I'm going to add, first of all, I have my planes I'd like to add in, so I'm got a little bit more copper space here than I'd like to be, but there's our HP, or horizontal plane, right there. Okay, if I just grab my pen here, this line along the back, the right hand side of the object right there, is an edge view of the VP, the vertical plane. This line going along the left hand side is the edge view of the EVP, the end vertical plane. And right there, the main one we're looking down on top of is the horizontal plane, and I'm going to just put a little note there, true shape. So it's a true shape of the horizontal plane. as we look down on top. So I'm going to just once again add a little bit of colour onto my views here. I think it helps so much with visualising what's happening with the object. I'll pause the video and I'll be back on in a couple of seconds and we will go through the elevation. Now that the bit of colour is added there, I think it just it really just puts a bit of structure on the question, shows what everything is. And we have our blue horizontal plane, the ground. We have our red here on the end vertical, which is the left wall of the room, and green here on the right, which is the main vertical plane, which we're seeing an edge view. So as you look down on top of the object, you're seeing an edge view of the two walls, and you're seeing a true shape of the floor. We're also seeing the true shape of what's happening inside the trace. So the trace of this axonometric plane across the ground here goes into the corner. This is a 90-degree corner, so when we draw our semicircle, we get our 90-degree corner and a true shape of what's happening inside that trace. That's the plan finished. That's all I need down there for now. I'm going to work on ahead, move on up to the elevation. I'll just take a quick look at my question again, just to see what we're dealing with up here. So as we can see in the question, point C is projected up, point B is projected up. We get a starting point parallel to the trace, same length as the trace as well, of course. We'll draw our semicircle. We'll bring the corner of the room, the z-axis, up and onto the semicircle, and that gives us the 90-degree corner of the room. The object still sits on the floor and it's touching up against the wall, and we'll see a true shape of the surface as well. So that's this one here. So as we're looking along, what we're visualizing this time is as if you're here and you're looking in along at this, and that's your left hand there and there's your right hand. Well, on your left hand side is an end vertical plane, it's an edge view, and on the bottom is the floor. So the end vertical plane is going to stand up here as an edge view, and then the floor is just under the object, and we basically draw what we can see. Let's get started. The last time when we came down to plan, we viewed down along the y-axis and projected parallel to that. This time when we're looking up at this elevation, we're projecting up along with the z-axis. So I'm going to take both points up. Again, just to make sure that this fits on the page, I'm going to just measure, what had I for this? I think I did some planned at about 74 mil or so. Is that correct? Yeah, 74 mil, I think, from that point on up along. I'll just go 75 there. That would be the position for the start of the elevation. So about 75 mil along. I think I'll have a little bit more free space up here this time, but that should work fine. This wouldn't really be a worry again if you just even turn your page portrait, but just so that it all records, I'm just staying with landscape here. There's the start of my elevation right there. I know this time that I can just bring the axis up, and again I'd often encourage students just to bisect the line anyway, but for isometric you don't need to. From the center of the line, I'll just test it first, just make sure that everything is falling in perfectly accurate there, which it's not bad. I'll draw my semicircle, and then I'm going to drop in, first of all, from this point right here to this point right here, and that's the floor. And from this point here to here, that's a wall, that's a vertical plane. I might drop in my object now, and we just have to see what widths are we seeing this time, what dimensions are we seeing. And if we just look back to the question briefly, what are we seeing this time? Well, we're seeing, as we look at it's the hexagon really that gives this all away. We'll see the 30 mil face of the hexagon here, of the hexagonal prism. So we're looking in here at this object. We're seeing the base of the pyramid touching off the end vertical, off the red plane in my case. So that's the red one up there. We're seeing the base of the pyramid touching off of that red wall right there. okay, which means that all of our dimensions, we'll be getting them from plan now in a while. We didn't have a measurement originally for the width of the object, so we just take it from plan. There is no number for that. So working up here, to get started, I'd like to start off with the base of the object. So I'm looking in from this angle at my object, so I'll just take right there, that's the full width of the object, and it falls in exactly in line with the corner of the elevation where the ground hits the trace, which it should be perfectly in line with that. The next thing I'm going to do, does it give me a height? That's the one I'm looking for next. I'd like to draw this pyramid in here, and the height it's giving, or the little note for height, is that in line with the top of the object, if we come parallel to the floor, parallel to the horizontal plane, across to the center, I get the apex, and I can draw my the pyramid in there. So I'm going to set my adjustable for this, make things a little bit faster here, and seems to be set from some previous drawing I was doing. So in line with the horizontal plane from this top point, so that's the overall size. I'm going to go ahead and bisect that top line, which will give me the apex. I could also, of course, have taken the distance here in plan and set it up there, but look, anything, whichever method works for you really. Now I can't heavy this in because I don't know how much of it is seen and how much of it is covered by that intersecting solid object, the prism. But that's it for now. I'm going to draw a center line down through the object as well. So that bisector I had up top, I'm going to just extend that on down through the object there. Next thing I'll do, I'm going to set off the faces and the edges of the pentagon. So what I'll do is, I have a center line going down through the object here. I'd like the same center line going through this one right here. I might just put all of this in with a colour right now. That right there is my center line. So the whole object is symmetrical to that line, left and right. So, and left is over here towards the invertical plane. There's the invertical plane. I'm going to just draw a similar center line. So if I'm splitting the object so that I can reference all the measurements from a center line, well, there is the center line right there. I'll take the distance out, which should be 15 anyway. So that's left and right of that center line right there. Left and right, that's my 30, and that's 30 total, and then I have left and right again to find the outer points here and here. Now what can I do with them? I know that this point right here goes down until it intersects with the face, and I know that this point here does the same. It goes down and intersects with the slope face. This one here goes down and this one goes down, and they both intersect at the same position, so they'll both intersect someplace there, but I'm not sure where yet, so I can't do any more with that. I can put the top on this object here. And that is about it for now, I think. I'm kind of stuck at this point. There's no more I can do now. At the moment, I can just heavy in a portion of that, but again, I don't know how far it goes. I can heavy in a little portion of this if it just helps with visualizing, but that's about it. Now that I know how big this drawing is, I'm going to just define a plane, just give it any definition there at all. I'm going to start again, helping myself to understand what's happening here. So it sits on the floor, and I'm using the blue colour for the horizontal plane of the floor all along. So I'm going to continue with that blue colour. It's touching up against the end vertical plane over here, so I'm going to use my red that I've been using all along for that. I'm going to annotate this guy as edge view of the HP horizontal plane, and annotate this as edge view of the red one. Again is the end vertical plane, EVP, and this one here then is the VP, and that again is a true shape. Now I'm going to just again pause the video for just a minute. I'm going to get some shading in there. So I've the green. So in every view we can see, whether it's a plan, an elevation or an end elevation that will go up this direction, we can see two edge views of two of the surfaces, and we can see a true shape of a third. So I'm going to get a little bit of green, a bit of green colour in here on this plane, just to define where it is. Once we're back on, then we're going to talk about the intersection of the solids and the points. But I suppose before we do that, we can even again pick up more marks and start off our axonometric with every bit of detail that we can add in. So I'm going to go colouring in. Pause the video if you like, get some colour onto your drawing, and when we're back on, we'll start off with our axonometric view. Now that I've that much done there, just one thing to note, just in case it's confusing anyone, I had used I used light green colour just for the top of the hexagon only, and then just to ensure that it stands out from the background, I'm going to say that the rest of the prism going down along is purple. So the green is just the top surface, purple prism going down along. That's as much as I can do, and I don't know where the orange, I basically don't know how far down the purple comes until it actually hits the surface. And to look back at the exam question, I'm looking at here, I'm looking at this part. So over here I have my orange base going up very roughly now. Of course, that's what my orange base is looking like, and then the purple surfaces coming right down in there and intersecting along a full line of intersection here, and then there's a lot more detail even going on around there and there. So it's all that detail that's still missing, and as I was saying there after the break in the video, that's what my object looks like. That's where my colour scheme is coming from really, and this guy here then being the main green vertical plane over here, and finally the blue floor, the horizontal plane down here. So that's just a very rough indication of what's happening on my sheet. What I'm going to do is I'm going to draw, just like they have here, I'm going to draw as much of the axonometric view here in the centre of the axonometric planes as I possibly can. I'm going to start off by drawing the base of the square-based pyramid, the apex of the pyramid, and drop in as much of the pyramid as I can, and then I'll bring the hexagon through next. So that's the plan for now. We project back up from plan in the same angle we projected down, in line with the y-axis. So, and what we'll find here is that we've actually no projections really. We've no projections to do because like everything just lines up the way that they've designed this drawing. The fact it lines up left and right, and through the center is on center anyway. So everything is already projected up. I project back down in the angle I projected up. So whatever angle I projected up to establish my elevation, I project back down at the same angle. So that right there. And I have an apex as well, and the apex is here, and it's here in plan, which is on center. So there we are. Like that's about it really. It goes from there down to the corner, it goes down to the front point, and it goes down to the left. should find that there's a 30-degree angle from going from the front here then out. It's not actually touching this point here. You can see things are fairly tight. I probably could have kept it up the page a little bit more, if about 5 or 6 mil of free space above, but it's not touching this corner here. It's just by chance that it's quite close. So it's down 30 degrees until it lands on the corresponding line up here. So there's my pyramid. Bit of brain freeze there. That's the base of the pyramid to the right. Base of the pyramid to the left. And that's about all I can put in there at the moment. What I might just do is I might grab the rubber and just lighten off the isometric or the axonometric plane traces. I might just lighten those three off just that little bit, and it'll help my elevation to stand out a little bit better. So just so that we can differentiate between the elevation and the axonometric plane there we are. So next job then is we're going to have to start figuring out the hexagon. So we have our hexagon in the plan. We have the points of 3, 4, so 1 at the end, 2, 3, 4 points in the elevation. So it's time to figure out what the hexagon looks like. If you want, you can start by projecting everything at the same time. Depends on what you're comfortable with. I'm going to just do one at a time. This one here is the one I'm going to start with because it's closest to the red plane, the end vertical plane. This is why the colour is handy. We have a red end vertical plane here to the left of the object. We have the red end vertical plane here to the left of the object. It just makes everything so much easier to visualise. That's point 1. I'm going to work clockwise. There's 2 and 3 parallel to the green, the back plane. There's point 4 at the far right, and point 5 and 6 out here towards the front where the person is going to be seeing this object from. So point 1 at the left, closest to the vertical plane. Point 2 at the back, closest to the green plane, 1 step in. Point 3 is the next one along. Point 4 is the furthest to the right, so the furthest away from the red plane this time. So go all the way over here. Point 5 is the next one in, and that will line up with point 3. Now 5 is the one that we can see, so I'll go 5, 3, because 5 is the one here that's out front and 3 is at the back. 6 is the next one, which lines up with 2, and again same story. 6 is the one we can see, so 6, 2. And that's our bit of labelling added in there. I think that the labelling is really, really key, because it just makes sure that when I start projecting now, there's no excuse really. I should be able to get all of these right. That was number 1 going up. That's number 1 coming down. And if you have a fine liner, pigment liner, or anything like that with you, maybe just add a little note in as you go along. It's easier than tracing every point after. I'm going to do 2 points at a time now, maybe for this. So there's 2 and 3 there. There's 2 and 3, and just step back a little bit and just see them and make sure of the correct points. There's number 2, 3, working up from 4 and down from 4. I think that's the right point right there. So up from 4, down from 4 is there, yes. And then I'll do 5 and 6 at the same time. So there's 5 and 6, which should be 3 and 5 line up, and then 2 and 6 line up, and yeah, take 6 on a little bit further. So that should be my last 2. Just make sure. Now, whatever we do, don't rush it at this point. I'm going through it nice and swiftly there, but just don't rush. Don't make mistakes at this vital kind of stage like this. So 5 is up along, and if the drawing is getting a bit busy, use 2 pens or 2 pencils. 5 is up along this line, 5 is down along this line. Where they coincide there is point 5. 6 up along this line, 6 down along this line, and where they coincide It's 0.6. What we should find is, because 5, 6 is parallel to the base, and 2, 3 is parallel to the base, and all parallel to the green wall, and don't forget that is defining the green wall, the X is there. 5 and 6 there should be falling on a 30-degree line, which is in line with the X-axis. 2 and 3 should be falling on a 30-degree line as well, if you're accurate. If you're not accurate, then these things could be off by a few degrees at this stage. And then from there we just join the dots. And that's the top surface right there. I had that coloured with this light green here in plan. Now, once again, I'm just trying to, basically, I'm building up as many marks as I can here, we'll say, if this was an exam scenario, but at the same time, I want to take my bit of time here to help you to learn what you're seeing in the video. So what I'm going to do, I'm going to take just a few minutes. I know that 6 is going to come down, 5 is going to come down, 4 and 3, and we don't know how far they go or anything yet. We'll have to figure all that out now in a few minutes. I'm going to just take a couple of minutes first of all to do this job, really important job again, just the same as before. You're probably starting to see the trend here. I like to add in my colour. I like to ensure that we are focusing on the understanding of this topic, not just on getting the question done. There's no point in getting one question done and being stuck for the next one. There mightn't be a tutorial for the next one, and there won't be a tutorial on the day of the leave insert anyway. So there's our 3 planes defined there. I now know that is all I can see along the y-axis where the object is dropped in. That is all I can see along the x-axis, and that is all along the z. I might just bring my y label down a bit closer right there. So I pause the video. I'm going to add a little bit of colour in on the planes there, even though again I don't know what the object looks like yet really in this view, but we'll get there next. That's the final job, is moving on. So if we just looked at our key terms that we had at the start, axonometric, isometric have been used. We've talked about traces, and that's about it. There's quite a few here that are still left to be explored. Now, it's not a very difficult drawing. There's not too much more drawing left in it actually, but I'm going to go through maybe 2 methods or 3 methods of finding the rest of this drawing and finishing it off. So first off, I'm going to pause, add a little bit of colour here, and then we'll get back and get this intersecting solids part complete. Now that we're back, we see that I've just added in a bit of colour there onto the planes, and I've started just shading in the object itself. I've done very little with the object, so I just showed a little bit of orange there to show where it sits down on the plane. That's all I've done. What we're looking for now is we're looking for our intersection of solids. We want to try and find all of the key points that are over here, where the purple faces come down and intersect on the orange faces. So a bit of detail involved here now. Really, like, this is a great indication here. That really helps, and it kind of shows us everything we need. The few key notes and key terms I had dropped down here. So axonometric is used, isometric is used. The objects penetrate each other. We talked about the traces of the axonometric plane. As far as I see, that's all we talked about. Interpenetration is mentioned in the question. Kind of, that's more of a term that came from the old leave insert. That's what it was often called, but now it's called intersecting solids, or intersection of solids is kind of the more common term that's used nowadays for it. The ones there that we're looking at the moment, though: pierce point, turning point or bend point, and an element. Okay, they're the ones that we have. And the other one I'm going to just add in that I forgot to drop in at the start is a section. Okay, so that's another real key part to this. So pierce points and turning, or bend points some people call them. So a pierce point is where an edge goes down. So if there's an edge of an object goes down and pierces into the second object, so that's a pierce point. Similarly, that's a pierce point where this edge goes down and touches at a point, and that's a pierce point here. And them two pierce points can be joined up to get part of the line of intersection. So that is a line of intersection there from this purple surface to this orange surface, but the full profile of the intersection wraps all the way around. If you have a full face, so this time the full face goes down and it just hits along the line of intersection, nice and simple, two pierce points. This face here crosses over the edge. If you cross over an edge, you get a bend point. So it's where the profile goes up to the point and bends back down, or it's a turning point. So it goes up, turns at that point, and goes back down a different direction. It'll do the same. This purple face here goes up to the bend point of the turning point and then goes back down, and that would be in hidden detail, so we don't need to include that. I'm going to start off with these 2 points here. So I numbered that 5 and 6. I'm going to find the point, exactly the pierce point for 5 and for 6, and the line of intersection along the front, and then I can put this purple face on the object. That's the easiest one to start with. We have there's a number of methods we could use here. So the first method and the easiest one is to do a section. So if we can see all the detail in one view, basically we can cut the object or section it to give us enough information to find everything in the second view or third view. So what I mean by that, we can just add in a section plane along 5 and 6. And we could do a horizontal section, we could do a vertical section. I'm going to do a horizontal section here. And a horizontal section along 5 and 6. Well, a horizontal section along the pyramid, if we just think about it first of all, that's the base of the pyramid. If I raise up a plane parallel to the horizontal, and if I cut, I get a profile parallel to the base of the pyramid, just that little bit smaller. So a horizontal section through 5 and 6 is just going to look like this. That's how it's going to cut the orange face. It'll cut the orange face from the point A to B. And the line AB is parallel to the baseline. So if I'll just do that much for now. Where is it first of all? I'm going to call that M to N, O, P is the front, and then Q is the apex of it there. So Q, and there's M, there's N in the back corner, O, and P. So just so that I have something to reference from here. So the line AB, which is my section cut line, well, it starts there on the M up to the apex. So A lies on M right there. That's point A. What I did say is that I can't find point B just yet because B is in line, it goes nowhere for me. Point A to B, that line is part of a horizontal section. A horizontal section through this pyramid gives you a line parallel to the base. So I'm going to do that. Parallel lines are parallel in every view. The base of the object is 30 degrees here. So if I come up from A across at 30 degrees, it gives me point B. That's a horizontal section through the object, which gives you a cut line parallel to the base. That's the start. That gets this thing going. That finds the pierce point at 6, and it finds the pierce point at 5, and it allows me to draw that. So that's the first job. What I'll find in is that I can add in a bit of colour, but what I'd like to do is see, can I finish off this side here? Well, it goes from 6 and it goes to this bend point or turning point, but that's all in hidden detail, so I don't need it. I can finish off this side right here. And there we are. Now that's about all I can do on that side for now. I can just add in that little bit of purple again here. So that's the purple face there, going down from 6 to 5, going down to the the two pierce points, and finding that first little portion of the line of intersection right there. So there's my purple surface, all added in now. I won't add the orange surface in yet, or the orange shading, because I don't actually know yet how big it is. I don't know where to finish shading up here, so there's just a little bit more to figure out on that one. But for now, there we go, we have a start. I know this is going to be orange all the way back here, and that's all I do know, but I can't actually finish it off out here yet. What we've also been asked to do is we've been asked to finish off this intersection detail in both views. So I'm going to take the pierce point for 6 and for 5 back up to my elevation in line with the z-axis, just like we did at the start. So 6 goes down here and it stops right there. 5 goes down, stops here. Just grab my adjustable set square now again, because I have it all set up. Again, what we should see is that 5-6 intersection is parallel to the horizontal plane. There, and there's the surface. 5-6 there. And there. So that's that surface. What I'm going to do now is I'm going to move around, and I'm going to, if I just grab the exam papers again, we're going to move. So that's 5 and 6 done. So there's number 5 right there, and there's number 6, and then I'm going to go towards number 4. But along the way to 4, I have this point here. What I might do though is I might actually skip that one for now. I'll get point 4, and then I'll come back to this one. Okay, so if I just skip it for a few moments, I'll come back to it again. I'm going to talk about 2 different methods actually here for finding number 4. So the first one will be do the same style method again, and that's our horizontal section plane. So now, and again, a horizontal section here would give a cut line parallel to the base. It's a different horizontal section, it's different heights. It's a much lower down horizontal section this time. But that's what it would look like, going from here to here. But we don't want to do that. I'd like to try something different. What I'm going to try is this again. I think that in this case, the horizontal, or that could also be a vertical section, of course, but that section plane would probably be the most accurate. But I'd like to just try out something different here and show it on video so that we're seeing kind of different methods of doing this. A line on the surface is called an element. So if I can put a straight line on the surface, so what did I got? M, N, O, that's point P. A straight line from point P through point 4. So 4 to P, and I keep this as accurate as I can. So that's a straight line on the surface. And it goes from point P down here to start. It goes through that pierce point at 4, and it goes up and it hits point, what do we call this one? Point R. Right there. So that is a straight line element that lies on this orange surface here. It goes from point P, it captures this pierce point, and it goes up to point R. Point R. I need both points. A line is but 2 points. So point P I have an elevation, and I want point R, it lies on the O up to Q, O up to Q. So point R up here in the elevation. It's right there. I want to draw the line that goes from P to R. And once I have that drawn, I know that that captures the pierce point 4. So I can just draw it. I can draw point 4 straight down to there. And that's it. There's the pierce point number 4. So that's a nice handy way. There's you're using a straight line element. I'll just note that. So there's our element method. And before that, we had our horizontal section cut. horizontal section cut which revealed a cut line parallel to the base of the pyramid. So, two different methods used to solve a very similar style problem there. I'm going to take that pierce point at number 4. I didn't even think of this, of course. It was already done for me. I could have just projected straight down, so there was no need of that. Point 4 is shown there, intersecting the face. But look, we've seen another method, so it lines up perfectly. That shows that the accuracy isn't too bad with me yet. Back to the book there for a minute, so, and we'll just see what this next point is like. So we've now done point 6, point 5, and point 4. I'm just looking for this guy right here, this turning point. So where is it in plan? Well, it's right there. This point in plan is the one I'm looking for. And once I take it up to the axonometric, I can bring it up to the elevation. I'm going to use a horizontal section cut for that. Now what we need is a little bit of imagination here. We need to be able to visualize what this object would look like if there was no hexagon in there. So the handy thing about this is when I go ahead and find one point, I'll kind of have solved a lot really. When I find this one turning point here, I'm probably also going to be able to find the second, third and fourth ones all at the same time. So what I'm doing here is this. I'm imagining that all I'm looking at on my page is just this square based pyramid here. So all we have on the page right now is our square based pyramid, and that's it. That's all we want to see. And there's a point on that pyramid along one of the edges right there that we want to work with, and that's it's the only one we want to work with. And what do? If I'd like to see that in various views, maybe I'm not getting the full story of it where it is right now. If I wanted to see that in various views, I might just bring a plane up that's parallel to the ground or parallel to the horizontal and do a section cut. So that's what I'm going to do next now. This little sketch might help me to visualize and see what's happening. Or of course, when you're coming back on these sheets, seeing them at a later stage, helping you to solve a different question, these might be helpful. If you kind of think of SolidWorks here, there's the top plane right there. The object is sitting down there on the top plane on the ground. If I grab that plane and rise it up, and in this new position, if I just told SolidWorks to section the object, well, the section I get, if that position was in line, the section I get there would be parallel to the ground. It would be parallel to the ground on all sides. So the section I get would be something like that. So that would be the section view. That's what I'm doing right now. I'm kind of disregarding a lot of what's shown in the question. I'm completely disregarding the fact that there is another object in there, and I'm just kind of working with what I want to work with and what I can visualize and see, and I want to get that. So by bringing an extra plane from parallel to the ground or parallel to the HP up until it's at a height that touches the point I want, and then I section the object, that's what I get. So let's go ahead and do it. As I've sketched here, the edges are all parallel to the base edges. The key point I want is my turning point right here. So parallel to the base edge from that key point. And as I said, what you will end up doing is, because this is all symmetrical, you'll end up catching all of the turning points at the same time, or the bend points as you might have been taught to call them. And there we go. That's the section that I've just sketched right here. Where can I find some points on that section? Well, first off, the easier one would be this one back here, the right hand side, this guy. It's on the line that goes from O up to Q. So O at the right hand side, up to Q. And I can project that up, and straight away I get a bend point right there. I can finish off this side of the drawing while I'm here. because it's solid from there down. I now know that point 3 goes down, and that point joins down here. So that gives me the right hand side of the drawing finished. I haven't really even used my section plane yet, or used what it's doing for me. I could have just projected that point straight up anyway. So there we go. There's one more surface. Just every little helps really. We'll just keep adding in the detail as we get it, and hopefully again the bit of colour will help to understand this and to visualize what's happening. What's next? We're looking for this line along here that brings us from that turning point. Of course, we went down to 4. I'm looking to go back up to the next turning point. We went down to point 4 right there. I want to go back up to a turning point and then down to 5. I want this pink section of the cut right there parallel to the base. So what angle was the base at? It wasn't at 45. The base of this was at 30. And parallel to the base, there we go. And that brings us down to our next turning point. We can bring 4 up, and we can bring the turning point down. I can now heavy in the portion of the pyramid that's actually visible in the drawing. I'll just go over these lines here once more just to make them stand out nice and clearly with all this shading that's going on. And there we get our intersected surfaces. Now, there's the purple surface as it goes down, and we end up getting our pierce points, number 4, our bend points and turning points across the edge of the object, and the pierce points here. And the line of intersection, or the profile of intersection, is all of the lines connected. So it's the full profile. What I need to do next is I'm going to just pause the video very quickly, but actually before I do, I'd like to finish off my view over here. Now, what do I have? First of all, 5 is going down and hitting, 6 is going down and hitting, and I have 0.5 and I have 0.6. I also have 0.4, which is out here, but I just don't have this point right here. So I'll just project that point up, which is there. So that point goes down to 4 and down to 5. What will be forgotten by some people in this drawing is that the same thing happens. It's a symmetrical object, so the same thing happens at both sides of the symmetrical object. So we need to go ahead and add this in over here as well. The great thing is, it's just, again, it's all down to this horizontal section cut. The horizontal section cut gives you a cut surface parallel to the baseline. So there's the baseline. I had my adjustable already set for that. Bring it up. And there's my line parallel to the baseline. I'm going to pause the video just one more time, add in the last bit of shading to define the areas, and have a quick chat to finish. So there we go, that's the finished question. It's almost a 1 hour video, really taking my time to get through this and to kind of go through a few different methods, even some ones that weren't even required, but look, they might help in some future questions. Just to recap once more, it was isometric, so we started off with our vertical y-axis and our 30-degree x and z, which gives us total angle between x and y there of 120. Y to z was 120 and z to x was 120. We developed out our planes, and we, first thing I always do, and I really do believe in it, not just for these tutorials but also for classwork, for your own revision and study sheets, the colour. and the notes. So the bit of colour and notes there really helps. And on that note, actually, I should add in that is right there is the HP, that this guy right here is the VP, and that this unused one we didn't project a view onto there is the EVP. The intersection of the planes is a little extra that was dropped in there, but nothing majorly difficult about it, I think. Tried to bring in a couple of different methods, and or elements, or horizontal sections, vertical sections, all dropped in there. So I hope this video was helpful. I think that if you can do this, you'll be able to approach most intersection solids questions and most axonometric questions. I suppose the main thing is with the axonometric that you're comfortable with curves and cut solids as well as intersecting solids like we have here. Thanks very much for tuning in. I hope it was helpful, and we'll see you for the next video.